Hello everyone, today we are looking at simple electronics with Tinkercad. There are some people who really want to get into electronics, but here's the case, they don't have the tools and then the equipment to start their electronics journey. If you are that kind of person, stay tuned. This video is actually for you. Don't forget to like, follow, share, and then subscribe. Tinkercad is a web-based software that can actually help you in most of your electronics projects, from circuiting to programming. So to start with, head on to any browser and type tinkercad.com, and then it should take you to the Tinkercad website. So that you need to click on the login, and then you can sign in as educator, students, or personal account. So you can use your personal account, log in with your email, and then you are at their websites. So after logging in, you head on to the create section. So the create, you can actually create things like 3D design, circuits, and then code blocks. So in this case, you're going to do the circuit. So you choose circuits. So after choosing circuits, your interface will open. At the far end, you have a resistor LED, push button, potentiometer, capacitor, 9-volt battery, breadboard, Arduino, a lot of components. So you have most of the components at your workspace that you can actually utilize, and you can also search for components if you are not finding your components. There will be a case whereby you will not find the components you are looking for in the software. The software does not have all the components. So I'll do another video showing you how to export components that is not in the software into the software so you can use it. So with this, you can actually create a simple circuit like this. There's an LED and a battery. So you can see, you can change the color of the LED. Here, you can choose red and to change to red. And then you can add a resistor. And then you can actually swap the terminals, as you can see. And then you can actually change the resistance value. See that now it's 1 kilo ohm. Let's say you want 220 ohms. You go here. You have micro ohm, mega ohms, so you choose ohms, and then you change the value to 220 ohms in order to protect your LED from burning. Yes. So after that, you actually do your connections. You connect the positive terminal to the resistor and then the negative terminal. So after that, you see start stimulation right there. So you click on start stimulation and you see your LED on. You see there is a problem. The LED is not well protected. So we need to increase the resistance value or reduce the voltage of the battery. So you click on stop stimulation to stop the stimulation. So today we are making a simple transfer circuit using Tinkercad. So basically we need a breadboard. As you can see, we have our breadboard here, which will actually host our LEDs. So with that, we need a microcontroller to do the programming. And for this case, we have the Arduino Uno available, so we go for that one. So with that, we place our LEDs. We're actually going to need 3 LEDs. So 3 LEDs, red, yellow, and then green. So we place the second LED, we change the color to yellow. So always the default color is red. So you always have to change the color to suit your preference. So the third LED, in this case, we change it to green. And then you can actually name your LED. So in this case, you're going to leave it like that. You don't want much work. Okay, so green, as you can see, you're done placing the LEDs. So now we head on to the wiring. So basically, I am going to connect all the terminals to the other side because there is a breakage at the middle. So in order to ensure continuity, we would have to connect all the terminals to the other side. So we connect the positive terminal to the other side, negative terminal to the other side. Same applies to all the 3. So after that, we would have to connect all the negative terminals of the LEDs together to the negative terminal of the red to this actually horizontal conductor right here. which is the negative. So you connect all the negative terminals together, negative of red, negative of yellow, and then negative of green to the port through the negative over there. So after connecting all the negative terminals together, we would have to connect the positive terminals of the LEDs to a pin on the microcontroller, which is the Arduino Uno for this case. So now we connect the green to pin 9 on the microcontroller, and then for the yellow, we connect it to pin 10, and then for the red, we connect it to pin 11. So after this, we would also have to connect the negative terminal to GND on the microcontroller. So in this case, all the GNDs have been connected together. So we just need one simple output and then we trace it to the GND on the microcontroller. So as you can see, our circuit is now complete. So we can head on to the sketch or the code. So for the code, you head on to here, it says code, and then the default is blocks. So you have to change it to text or blocks plus text. So in this case, we are going to do C++. So it's basically text code. So we are doing text. So you have some default code right here, which actually generates automatically depending on the circuit that you built. So we want to write our own code, we delete and then have the code written already. I will just have to paste it. So after pasting your code, you actually go through and then you start simulation. But in this case, our circuit is working all right, but then there is a problem, right? There is a problem right here. So the problem says current through the LED is 53.5 milliamps. Our recommended maximum is 20.0 milliamps. So this is actually basically the current. So basically we need a resistor to oppose the flow of the electric current, which is to actually protect the LEDs, right? So with this, we actually swap these connectors, the connectors for the positive terminals for a resistor. So basically, I'm going to choose 220 ohms for each LED. So basically, we swap all the connectors of the positive terminal to 220 ohms. So we do same for the yellow and then the red as well. And now let's start the stimulation. Boom, everything is in order, everything is working perfectly, no more errors. Our LEDs is well protected with what? With the resistors. You can see the code you wrote is actually working perfectly. So from red and then green, which means you can go, and then yellow, which says get ready, red, and then you stop. Yes, exactly how the traffic light works. So let's stop stimulation. You can actually go back to your code, make changes, and then you start the stimulation. But bear in mind, anytime you want to make changes in your code, you would have to stop the stimulation. If not, it won't work. Stop the stimulation before you actually do any changes to your code if necessary. So after that, you can actually go to the schematic view of your diagram. You see how simple it is. This one, you could use Bluetooth or keycard for it. But for here, it will be generated automatically. Just pick and place and then it will be generated for you automatically. See how beautiful our schematic looks. You can also download it onto your PC or whatever and use it for whatever you want to use it for. So basically, that's Tinkercad. Thank you for watching. Don't forget to like, comment, share, and then subscribe.